Good morning to all. I am Dr.A.SETHUPATHY, Assistant Professor, Department of Mechanical Engineering, SNS College of Engineering. Today we will go to discuss about hydraulic gradient line. In this topic is contains in fluid mechanics and fluid through pipe in circular conduits. So the hydraulic gradient line is nothing but the graphical representation of the pressure or energy line and provides essential information for the understanding fluid flow in various systems. So the Bernoulli's equation says the fluid pressure is overall through pipe is same, but in hydraulic gradient line the fluid is flowing through a slope or taper sections. What are the variations in the pressures lines? It will be graphically represented by this hydraulic gradient line. So we will go through in this topic. So hydraulic gradient line is graphical representation of the energy line. So the energy in the top surface of the fluid reservoir and how it goes to bottom surface of the fluid reservoir and how it will be changed in the outlet of the fluid. So this graphical representation includes in the hydraulic gradient line. So definition of hydraulic gradient line is the represent the energy losses and gains along a fluid flow path connecting the piezometric heads of different points. So we join the different heads in the fluid through the pipeline or some other area. So the representation of the graphical line is called the hydraulic gradient line. So calculation of hydraulic gradient line, how to calculate this and how to draw the hydraulic gradient line. So head loss calculation, the sum of major and minor head losses along the flow path determines the position of the hydraulic gradient line. The second one is equations and formulas. Various equations such as the Dorsey-Weisbach equation or the Hazen-Williams equation can be used to calculate the hydraulic gradient line. The third one, piezometric head. Measurements of piezometric head at different locations help determine the HGL, hydraulic gradient line. So importance of hydraulic gradient line in fluid flow. First one is efficiency analysis. The hydraulic gradient enables engineers to assess the performance and efficiency of fluid flow in system. So we are using the fluid in transfer one area to another area, and we are using some other machines or equipments to run with this fluid aid. So these type of areas, the performance and efficiency of the flow is how to measure. This is usually in the hydraulic gradient lines. Then pressure distribution, by identifying high and low pressure areas, the hydraulic gradient line helps in designing appropriate control measures. The third one is flow visualization. The hydraulic gradient line visualizes changes in fluid flow paths, facilitating troubleshooting and optimization. So these are all the importance we are using in the hydraulic gradient lines in fluid mechanics. So factors affecting the hydraulic gradient line. So what are the factors will be affected? Fluid flowing through a pipe. So first one is pipe characteristics. So diameter of the pipe and surface, smoothness or roughness of the material of the pipe. So these are all the major hydraulic gradient line losses. The second one is fluid properties. So which type of fluid we are using in the system. So viscosity, density, temperature affect the energy losses and gains within the flow. The third one is system constraints. So that is the obstacles, bends, valves, and pump alter the HGL within a system. So the three major factors affecting in the hydraulic gradient lines. So example of hydraulic gradient line in different scenarios. So water treatment plants. So illustrated the impact of various treatment process on the hydraulic gradient line. Then pipeline network that demonstrates how a complex network of pipes and fittings affects the HGL. The third one is hydropower plants. So highlights the connection between dam turbines and HCL for power generation. So these three main areas are the different scenarios of hydraulic gradient line used in the fluids. So challenges in maintaining a desired hydraulic gradient lines. First one is sediment accumulation. So the wastes, fine grain wastes are sedimented in. So accumulation of sediment pipes or channels distribute the smooth flow affecting the HCl. Leakages and cracks. So leakages and cracks in the system can cause energy losses and change the HCl. The third one is maintenance practices, inadequate maintenance, such as infrequent cleaning, leads to deviations in the hydraulic gradient lines. So conclusion and key takeaways. Visualization tool. The hydraulic gradient line serves as a valuable tool for visualizing and analyzing fluid flow systems. So what are the parameters in optimization? So understanding factors affecting the hydraulic gradient line as assists in optimizing system performances. So maintenance importance, maintaining the desired HCl ensures efficient and reliable fluid flow in operations. Thank you.